Good morning, everybody. So today we'll be discussing on IP MPLS. I hope you all are able to view my board. People on the WebEx, on the Zoom meeting.
Visible, yeah, it's visible.
Okay, great. So in the last session, we discussed on various kind of VPNs, IP networks, how to communicate between different networks, how to communicate within the same subnet, same network. So we all understand that if it's a same subnet, then we do not need a router. We can use a switch to make the communication, and that communication happens on data link layer. And if there are two different networks, two different subnets, IP subnets, and we want them to communicate with each other, we have to use a router which works on network layer, layer 3. So we count the layers from here. Physical is layer 1, data link is 2, network is 3, transport is 4, session is 5, presentation is 6, and application is layer 7. So this is the layer where routers work. This is the layer for switches. So this is a recap on what we discussed in the last session. So now we will discuss on a technology which works in between these two layers, layer 3 and layer 2. So this technology is called MPLS. Started somewhere in 90s. I would say early 90s. People started using MPLS. So this one makes use of the good points of switching layer as well as the routing layer. See, in switching layer, you work on MAC addresses and Ethernet frames. So the debugging becomes very complex. So if there is a problem in L2 link, L2 layer, it becomes very difficult for a network engineer to troubleshoot it. However, on layer 3, when it is more of IP communication, it becomes easier to troubleshoot, as you have got multiple tools to troubleshoot, like ping. Most of you must have used ping to check the connectivity. If the ping response is back, then you understand that the host is alive and host is reachable. So, but the switching or the actual packet processing, packet forwarding is very fast at layer 3. At layer 2. Why? Because the complexity increases while we move up the layers in the OSI model. This whole is OSI model. So physical layer is all about different kind of connections, connectors, cables, voltages, bits, bytes. So if it's an RJ45 kind of connection on Ethernet, so that will come under physical layer. So it is very simple that two things are connected and there is a communication between two interfaces, so that we can check very easily that physical layer is up or down. So we have various kind of cable testers or fiber analyzers, fiber testers to figure out whether the physical media is fine or not. Now with data link layer, we have the switches. So we have to check the MAC address table, that what all MAC addresses are learned in the data link layer to make the communication happen. In the network layer, we need the IP addresses of hosts to ping them to check whether the communication is happening or not. So the headers on the packet keep on changing or becoming complex. So in IP layer, in network layer, there is an IP lookup in order to make a communication happen. So a router will check its routing table. So routing table is a place on the router memory where it has all the routes. So routes will be all directly connected routes. So directly connected are the routes which are the networks directly associated with any of the interfaces. So I'll write here, directly connected routes are like, if this is a router and there are three interfaces. This is 192.168.0.1/24. This is 192.168.1.1/24, and this is 2.1/24. So all these networks 192.168.0.1/24, 1.1/24, 2.1/24, all these networks are directly connected to this router because they are directly terminating on the interfaces of the router. Okay. So now we understand two things. Switching data link layer is faster but complex to debug. IP is very convenient but a bit slower than switching. So what happened is we designed a technology which would make use of good points of both these layers, layer 2 and layer 3, and we termed it as MPLS. So MPLS is called multi-protocol label switching. So what happened is, instead of making the switching decisions or forwarding decisions on IP address and network, we decided to make the switching decisions based on some tags or labels. So we started putting labels and we tried doing label swapping between the routers. So if I have to go from router A to router D, there could be 10 routers in between, and each router can give me the label to go to next router. Instead of making the IP lookup, I'm doing a label lookup, which is much faster. So we started calling it layer 2.5. The MPLS would work on layer 2.5 because it is combining the features of switching and routing. So I'm making a small sample network here. So we also learned some terms like PE routers, P routers. So PE router is called provider edge router. So provider means it is a service provider network. Edge router means the router on which the customer is getting terminated. So if here is a customer CE is connecting to service provider network here. So this router is a PE router, provider edge router. And all other routers which are only doing the packet switching in MPLS network are called P routers, provider routers. Okay, because there are no customers terminating on the routers in the core. This is a generic topology most of the service providers would have. There could be service providers where they would want customers to terminate on some of these routers also. So this also becomes a PE router. Okay, so now these P routers are also called LSRs. Why LSRs? I'll tell you. LSR stands for label switch router. So why it is called LSR? I'll tell you. Please ask your queries in case something you find it difficult or you're not following anything, you just ask me. So this is, I've made a scenario with a customer with two branches. So one is CE1 and another one is CE2. So CE stands for customer equipment. Customer equipment. It's also called CPE. CPE stands for customer P stands for premises. So premises means if I am the customer, if this router is in my premises means my office, my POP, my home. So it becomes CPE, customer premises equipment. Just like a DSL router in my home, that is my CPE, customer premises equipment. Okay. So I have got same customer, branch 1 with CE1, branch 2 with CE2. You can take an example of a geographically distant location. Maybe this one is Noida and this one is Pune. CE2 is Pune, suppose. And there is a service provider network in the middle. This is the PE router in Noida. So I call it PEN. This is the PE router in Pune. So I call it PEP. Now what happens is this CE is connecting to this router and this link is all IP link, either IP link or Ethernet link. So difference between IP link and Ethernet link is IP link is L3, Ethernet link is L2.
L3 means layer 3, right?
L3 means layer 3 and it has an IP. Okay. So layer 3, immediately as soon as you say layer 3, just connect layer 3 with the network layer and IP. So if there is an IP, there is a subnet, it is layer 3. If there is no IP, it's only switching, it is layer 2, L2. So this CE to PE link can either be layer 3 link or layer 2 link. So layer 3 link, if it is, then it will be called as layer 3 VPN, L3 VPN. I'll get onto the VPN later on, but just I'm giving a differentiation between the layer 3 and layer 2. So this CE-PE link, this is called CE-PE link. This is CE-PE link. So it could be either layer 3 or layer 2. If it is layer 3, then you might have some routing protocols running between CE-PE. It could be either BGP, it could be OSPF, it could be static routing, it could be RIP. So that is called CE-PE routing protocol. So routing protocol is like what we discussed in our previous discussions, that we can have static routing at all the places, but if we want to have dynamic routing, we use protocols where we need not to define static routing all the time. All the routing information gets exchanged between 2 or more routers dynamically, automatically. Okay. So CE-PE link, then you need to know about CE-PE protocol. So it could be, this is a routing protocol, it could be either BGP, could be OSPF, could be ISIS, could be RIP. These are all routing protocols. RIP is routing information protocol, ISIS is intermediate system, OSPF is open shortest path first, BGP is border gateway protocol. So layer 3 link, layer 3 VPN, layer 2 link, layer 2 VPN. So if it is a layer 2 link, there will not be any IP here on PE. If there is an IP on this interface, then it's a layer 3 link. Okay. So now, this is either Ethernet or IP. Now, once the packet from CE reaches this PE, then what will happen is, this PE will encapsulate the packet with a label. So the label could be a numeric value. A label could have a numeric value like maybe 7008 or something like that. So there will be an in label and an out label. So for every interface, there will be an out label and one in label. So these routers are distributing the labels in out for each interface, and they use a protocol to know about these label distribution, and that protocol is called LDP, label distribution protocol. Now, once each router has, the interfaces has some labels. So if I have to go from here to make this VPN work, I just have to switch the labels. So this router, what it is doing is, these routers in the middle, they are just swapping the labels. Packet आया, पुराना label हटाया, नया चिपकाया, आगे भेज दिया. And that is why they are called label switch routers. The P1s. Now, once the packet reaches the last router, which is again a PE router, then it will strip the label. Strip the label means label hata dega. So PE routers do label stripping and label imposing function. Because this is again either an L2 link or L3 link. Because this is CP connection. It doesn't understand MPLS. MPLS is starting from provider network. So PE router is a router which is either imposing or removing the label, or the MPLS starts from the PE router. Now what happens is, so this is about MPLS. Now what happens is, if you want to have multiple customers connecting to the same PE, you have to slice your PE into various small virtual parts, so that for each customer it looks like as if this is connected to his own new PE. Because it will be very costly affair for the provider to have one PE for each customer. So then this PE will have to be divided virtually, and this division of PE is done in the form of VRFs. VRF. So VRF is called virtual routing function. So PE is divided into multiple small slices per customer slices, and that slice is called VRF, virtual routing function. Each virtual routing function holds the specific routes for a particular customer, and that is why even if you have 1,000 customers connected on the same PE router, and maybe most of them might be using some IP addresses like 192.168.0.1, or maybe it is an overlap of address, but still no two customers will be able to talk to each other. Their network and routing information will stay separate from each other with the help of VRF.
So in that case, each packet will have a different label, right?
Yes. So the packets which are the routing which is in separate VRFs will have separate VRF label.
So that it will
yes.
Each packet
correct. That is how. So that is more on MPLS functionality, how it will happen inside this network. So I will not go deep into that functionality because you guys are more inclined towards the software part of it. So I want you to understand on a high level, how does it work? I would not expect you to know how the labels are getting switched, how to check the label information database and all. So what happens is, from each VRF to each VRF, there is, or from each PE to each PE, there is a path which is formed based on the labels, and that path is called LSP. LSP. So this is called label switch path.
So basically, what's the role of label?
Okay, so अगर label नहीं होते, forget about labels for a moment. Now, if there are no labels, then how would this router come to know about this router? It will come to know through IP protocol. Okay, so if a packet comes here, you have to read the IP header for destination, and then on each router read the IP header and check the routing information base, and then forward it to the next interface, right? So that checking of IP header and checking of the routing information base is a time consuming and lengthy process. So instead of that, what we did is we started distributing labels.
So that will be included only on the case of like when we will have a network L3 layer, right?
So this is only when you have a service provider big network which is serving multiple customers. If it is only a network of 2 or 3 routers within a same enterprise, then you don't need MPLS. Unless you want to have different departments connecting to some PEs and you want to keep their routes separate and all that stuff, then you might need MPLS. So now to your question, whether L3 or L2, I will come to that. So this VPN could either be L3 or L2. So why I say so? Because if the network on this CE, the IP network on this CE is same as IP network on this CE, then it is an L2 network. Why? Because this whole provider MPLS is acting as a big giant switch for the customer. इस switch में एक port इधर है, एक port पुणे में है, you connect and same network is talking to each other. So that is why you don't need an IP here, because CE का IP यहाँ पे है और उसका next क्या होता है? Gateway होता है. Gateway यहाँ पे जरूरत ही नहीं है क्योंकि same network है, यहाँ से बात करनी है. So maybe it is using same network like 192.168.10.2 here and 192.168.10.1 here. So it is same network and you need an L2 MPLS VPN to connect same network within 2 different locations. Now suppose the network here is different. Instead of 10, here it is 12. 192.168.12.1. So this 12.1 is different than 10.2. Then you need an MPLS L3 VPN to connect, because 12.1 you will need a gateway in the same network. So 12.1 is here, so 12.2 will be here on the provider edge, so that this can talk to this, and then the routing or MPLS will do its magic. It will come till here. Here it is 192.168.10.2, so 10.1 or some IP in the same network will be at the PE router, and then it will talk to, because simple है, IP 2 router तभी आपस में बात कर सकते हैं same link पे अगर same subnet होगा. अगर अलग-अलग subnet में IP दे दोगे आप, यहाँ पे कुछ और, so this link will be unusable.
L2 and L3 routing will be same. Internal routing.
Internal routing would be on label switch path. So there is a small difference here. So routing will be same. That is for sure, because every PE will have their own IPs, their own labels. So label switch path will be similar, but there is a difference in L2 VPN and L3 VPN. So L2 VPN you can have a direct X connect tunnel. You can. I'll just write it here. So in case of L2 VPN, you can have a direct X connect pseudo wire, PSU pseudo wire tunnel. So why pseudo? Pseudo means virtual. Wire means tar. So this term pseudo wire comes from the old circuit switching days, where in order to make a call work, if suppose I am calling from my landline, I used to call your landline, so it used to be a continuous circuit which used to happen between the 2 communication devices, and then the communication would happen. So it's like a wire. So this is a pseudo wire because this is a virtual wire on IP MPLS network, and it is also called X connect. So what will happen is there will be pseudo wire from here to here. So this pseudo wire can be identified by a pseudo wire label. So if any packet from this PE want to ride on this pseudo wire, so you put that label and it will ride on this pseudo wire. Understood? Now if it is and it is called X Connect. Remember this, X Connect.
So
Okay.
this needs to be
Configured.
first.
Yes. So I will come to now today. My intent is to finish this MPLS concepts, layer 3 VPNs, and also give you guys an understanding of what is the challenges the service provider face or the network engineer face, because this all has to be configured by some network engineer. So the parameters in order to configure this is huge, and there is a lot of configuration which used to happen on PE routers, P routers and all, and this is all we will try to automate using NSO. Okay. Yes.
There was a SRD PEC bundle maintenance also.
PEC
Bundle maintenance.
bundle maintenance. Yes.
That is one of the SRDs we have done. So you have the SRD docs. Whatever you are explaining already, like
Written in the SRD doc.
Not written exactly, but something like this one.
Yes. So now bundle interface, as you are talking about the bundle. So I'll tell you, this is the PEC link. Now, if it is a single link, it is one link. If it is multiple links clubbed together, so it is called link bundle. How it happens is, suppose this one link is a gigabit link. So it is 1 gigabit per second speed. Now, if I want, suppose 2 gigabit per second speed between CEP, I will have two links. I will club them and make a link bundle and make a virtual interface. So I will have like, this is link A, this is link B, and I make them part of bundle. And this bundle will become a virtual bundle interface. I can say bundle 0 by 0, and I will put the IP address here. Instead of putting IP on each link, I will make both these links part of the bundle, and then I will put the IP on the bundle interface. So the overall capacity of this bundle interface will become 1 Gbps plus 1 Gbps equal to 2 Gbps. So this is what will be referred in the SRD. So going forward, if there is any new SRD which is coming in, so maybe we can have a discussion on the SRD, and I would maybe I can go ahead and explain you the SRDs, or you can go through the SRDs and come to me with your specific questions, and we can discuss specific parts. Means depending on project to project. This I would rather do it within the projects, because doing it in a big forum might not make sense for the others who are not associated with that SRD. Okay. So that is about the bundle VPN. And yes, now if I'm doing an L3 VPN, so there is a BGP service, BGP between all the PE routers. So there is always a label for the service. For L2 VPN, it's an X Connect. BGP is not used. It is only the IGP. IGP means Interior Gateway Protocol. So that is like this router should know the IP address of this. So there is a dynamic protocol running between all of them. It could be ISIS, OSPF, or if nothing, then static routing. And LDP is required for label distribution. And you can have the X Connect from anywhere to anywhere for L2 VPN. For L3 VPN, all the PE routers should have a BGP connection, because BGP is used to distribute the L3 customer routes from one PE to another PE for L3 VPN. So I'll write a few things for L3 VPN that if you know, it will be good. So L2 VPN, as I wrote, it is X Connect pseudo wire. For L3 VPN, it is VRF, which is virtual routing function. Second is your PE protocol. Could be either BGP, OSPF, ISIS, or RIP. Then there will be RD and RT. RD means route distinguisher. RT means route target. So what will happen is, if there are multiple VRFs on PE for L3 VPN, there are multiple customer routes coming in for each VRF, then how do we segregate the customer routes when we are distributing it through BGP? So we use RD. So RD is like on each route we put another tag, and it's also a numeric tag. So this is called route distinguisher. So for each customer, if suppose each customer has 100 routes or 50 routes, so for all routes originating from same customer, we put same RD, so that it remains differentiated. Route target is opposite of RD, which we import in order to put customer routes from another location to that VRF. Because from each PE, we advertise the customer routes with RDs. And on each PE, we import the customer routes using RTs, route targets. So VRF contains RD and RT. This is all for L3 VPN. So you don't need a VRF for L2 VPN, because L2 VPN is just a simple X connect, because there are no routes. So as soon as the packet is ether frame is coming to the PE router, you put it in a X connect tunnel, and it gets encapsulated, goes to the other PE, gets removed from the tunnel, and goes to the same network. For L3 VPN, this is VRF, you have got CEP protocol, RDs, RTs, something like that.
So
now,
in case of L3 VPN, suppose there are 10 packets, so all 10 packets will have the same path, or it will have different path?
Okay, so this depends on dynamic routing protocol within the network. So the BGP from PE to PE will remain the same, but suppose it's taking this path as the shortest path using the IGP. If this link fails, then maybe the path will be this, but BGP remains from here to here. The path can, so whatever is the path, if there is load balance or something, so all the packets will take similar path.
Now all the routing districts RD will be same for all these packets.
RDs will be same for packets for same customer. Yes.
सर इसमें पैकेट लॉस का कोई वो नहीं होता चांस?
होता है, बिल्कुल होगा पैकेट लॉस. पैकेट लॉस होगा अगर कोई नेटवर्क में, अगर ये दोनों लिंक, यहाँ पे ये भी लिंक कट गया, ये भी कट गया, तो पैकेट लॉस क्या, पूरा ही पैकेट लॉस हो जाएगा. Because there is no, see, the layers has to happen from, जैसे मैंने OSI layer बनाया था, from physical to data link to, अगर किसी भी layer पे प्रॉब्लम है तो obviously physical layer is the mother of all other layers. If there is no physical connection, nothing will happen. Yes, correct. So you will have alarms on routers that the LDP is failed between two routers, IP protocol is failed between two routers, even this interface is going down on two routers. So you will have alarms like that. So now we will discuss quickly on some configurations, and then we'll move to the challenges.
So जो ISP होते हैं, ये सिंगल एक कंपनी हो सकते हैं या मल्टीपल भी यूज हो सकते हैं?
So there are multiple topologies. So there could be one service provider or carrier. There could be two carriers between two customers. ये कैसे हो सकता है? ये ऐसे हो सकता है कि suppose I am in UP and I have got Tata MPLS here in UP. So I am connected to Tata MPLS PE router. This is Tata network. I am in UP, so my CE is connected to Tata MPLS. Now in Mumbai, let us suppose I don't have Tata network. I have Airtel here. So I am connected to Airtel PE here. Now Tata and Airtel can connect to each other, and this is called NNI. NI. Network to network interface, and can exchange my routes between these two in a secured manner so that my CE can talk to my other CE. So this is most of the time, this is option B NNI. It's called, in MPLS terms, it's called option B NNI. Option B NNI. So here, these are two PE routers, and there is an eBGP here, and this also switch the labels. So here this eBGP distribute the label between these two, and then the VRF from here can be exported till here. Stretched till here.
सर लास्ट ऑफिस में क्या था, मतलब एक वीडियो अपलोड करनी थी, तो कोई डिवाइस इन्होंने परचेज किया जिसमें 4 सिम लगा दी तो वो एक क्लब हो जाता है, जैसे ये बंडलिंग की बात चल रही थी ना, तो
4 सिम लगा. बेसिकली वी आर टॉकिंग मोर ऑन द इंटरनेट फ्रंट कि इंटरनेट की स्पीड कुछ बढ़ा दी होगी.
वो मतलब डिवाइस था.
So what will happen is, such kind of devices, if you have multiple SIM cards, so we are talking about mobility, LTE kind of internet kind of scenario. So there, if you have multiple SIM cards, like Reliance का भी है, Airtel का भी है, आपने 2 लगा दिए. So what will happen is, it can have 2 bearer setup, and it will load balance your traffic. Means suppose if there are 10 users connected to that device, so 5 users it will try to push through Airtel, 5 users it will try to push through Jio. So the actual speed the user is getting will be much more better if you are using a single SIM. So there could be devices like that. That is very
Could be like a router.
Yes, it's a router. It's a router.
It will load balance the
Yes.
different traffic.
It will load balance the traffic. So for L2 VPN, the configuration on PE is PE configs. So what all are required to configure L2 VPN? One is your CE-PE interface. So PE interface, where CE is connecting, PE interface. Then your pseudo-wire ID number. Remote PE IP. Only these 3 things are required, and of course remote PE name or remote PE name or IP means it is the same thing. These 3 things are required in order to configure an L2 VPN. तो अगर एक PE है यहाँ पे, एक PE यहाँ पे है, and you want to create an L2 VPN between these 2 PEs, then you need these 3 things. Which is the interface where my customer is connected to. So if the interface is gigabit 0 by 0, you need this. You need the IP of remote router. So suppose if this router has an IP of 1.1.1.1 and this router has an IP of 2.2.2.2. So you need the IP of remote router, this one. You need
Remote interface भी चाहिए.
मतलब same information you will need on both the sides. Here also you will need the remote, this interface, which is the customer CE-PE interface, CE-PE connection. So if it is connected here to gigabit 0 by 0 again, so here also you will need this, you will need the IP of this one, and you will need the pseudo-wire ID. Pseudo-wire ID. So these 3 information, if you have for both the routers, you can make the L2 VPN.
And pseudo-wire ID will be same for both sides.
So it is good to have same for both the sides. However, the pseudo-wire ID has local significance within the router. So you should not repeat the pseudo-wire ID within the router, but it is more dependent on the remote IP. So if this router you have put this as the remote IP, so the pseudo-wire will be like this, and here if you have put this as the remote ID, pseudo-wire will be, so if those 2 configurations are there, the pseudo-wire will get established. And this is assumed that MPLS is already running between these routers. तो बहुत ही सिंपल कॉन्फ़िगरेशन जो इंटरफेस पे होती है, जो ये गीगाबिट 0x0 इंटरफेस है, ये इस पे you will just do xconnect, sudo wire ID, remote IP, encapsulation, that's it. So I'll show you some small configurations on L2 VPN and L3 VPN.
जो xconnect है ये दोनों साइड्स पे
दोनों साइड में कॉन्फ़िगर होगा, और ऐसे L3 VPN में the configuration is much lengthier and that also you have to do on both the sides.
ये config में जाके अभी execute होता है.
Config में जाके execute होता है. तो अभी जो challenge होता है network engineer को, it means he has to configure this on both the sides. If there is any parameter which has gone wrong, then whole configuration he has to revert, and while doing manually maybe some configuration will still remain there, then it will create problem for other customers or whatever. So there could be outages, there could be slippages, and this is like a lot of manual effort, checking each router, checking how to do, what to do. And this is L2 VPN configuration is still very small. L3 VPN is very big configuration, and L3 VPN can have various topologies, like a mesh topology where everybody is talking to everybody. L2 VPN is pseudo-wire. Pseudo-wire only has 2 endpoints. So it can either be an L2 VPN can be pseudo-wire or can be a VPLS. So VPLS is like a bigger switch with multiple endpoints. So multiple points, point to multi-point. L3 VPN is always point to multi-point, and could be a mesh topology also, that everybody talks to everybody, or a star topology where all the branches are talking to central location. So now what we started doing with NSO is, we started treating this configuration not as individual box configuration, but we created data models for the configurations. So how the data models work is, just like in programming, you have a subject called data structures, where all of you must have read and implemented binary trees, linked lists, and different kind of data structures like arrays, stacks, queues, FIFO, LIFO, all that stuff. So similar stuff we started doing for network, that if we know the configuration of a service, let us create a container, a config container. Which is like a khacha, cookie cutter. So cookie cutter is like if you are making biscuits or cookies, and if you have a special shape cutter. So if you have the dough, you just keep pressing the cookie cutter, so you will have all your cookies in the same form and same shape. So that is what we do for the services. So the containers which we make for services are written in a language called Yang. So Yang is a data modeling language. And netconf is the data management or the network management protocol. Netconf is network management protocol. Both of these are IETF standards. IETF. IETF is the standardizing body. So both are IETF standards. So the vision is to have all services modeled in Yang, and all devices, be it any vendor, support netconf, so that we convert Yang into XML-like configuration and push it through a protocol called netconf. And netconf is more like a diameter kind of protocol, where there is a handshake, there is a candidate DB. So just like a web service, it is also like a web service, that you push the payload in Yang towards the device, and device checks it, puts it in candidate DB, and when it checks that everything is fine, it commits it to its production database. Something like a web service, how you push data to a web service. But netconf is something which not all the vendors have support for as of today. So still we are using YAM to model the service, but sometimes we don't use netconf because the device do not support netconf. So what does the device support? Device supports something called CLI. Command line interface, that the black and white window, which most of the network engineers love to use. So the bigger problem for the service providers is if they are using a multi-vendor network. So multi-vendor network would be like they have routers from different vendors, be it Cisco, Alcatel, Juniper, Nokia. So each router will have a different CLI interface and different language. So as a service provider, they will need network engineering team for different vendors. So there will be separate network engineering teams from different vendors, because the guy who knows Cisco is not compulsorily true that he will know how to configure a Juniper also. And a guy who knows Juniper, it's just like a guy who knows Java is not necessarily might be good in Python. So for all this, but if I see it from a business angle, whether it is Cisco or Juniper or anything, it is a router for me. So why should I use multiple teams, multiple skill sets to configure multiple kind of boxes? Because my business is to provide service to the end customer, and I want to get the service configured quickly, without any errors, without any challenges, and with least of manpower. So for that, as a service provider, I might need something which can model the service and then give a UI interface to any person with not any specific skills to just put the mandatory fields and get the service done. So just like for L2 VPN, I told that there are only 3 mandatory fields. Like if you know the interface, if you know the pseudo wire ID, if you know the remote IP, you can configure L2 VPN. Doesn't matter whether it is Juniper, whether it is Cisco. If you don't know how to do the CLI, it will be difficult. But if you have modeled it in NSO, NSO will help you do it. It will just ask those 2-3 parameters in English language. You put it there, you hit commit, it will be done.
It will convert automatically the target level.
Everything. So there is a concept of NET in NSO. So NET is network element driver. So NET is also a piece of software which NSO uses to communicate to the devices. So if you have 3 vendor devices, Juniper, Cisco, Alcatel, you will use 3 nets, one for Juniper, one for Alcatel, one for Cisco, and this net will convert your generic configuration to device specific configuration and push it towards the device. And the service will be modeled in YAM irrespective of devices, because the service has standard parameters. Variables are same for all the vendors, but how you write the configuration in each of the vendors is different. So NET does that trick for us. So if I go to quickly talk about NSO architecture, what's the time? If we are running out of, we have 5 minutes, right?
So Mohit,
Yeah.
Who provides this net? So this vendor, or we have to write net code?
Okay, so TLF is Cisco acquisition. It's a Cisco product. So Cisco BU engineering provides nets for various vendors. There are more than 200 nets available for various vendors. If there is a new vendor which comes in, Cisco asks to access the device. for like 2 to 3 weeks to get all the configurations, and the Cisco engineers develop the net, software engineers. So let me put it this way, all of you have the capability to develop net.
Which language it is written in?
Simple, Yang, Java and Python. That's it.
Net is written in Java.
So
it's like you write the YANG model first, and then you write the
Map it.
code of Python code to convert the YANG model, and then you push it into the device.
yes. So it's all about making the models, making the right data structures.
NSO package is what is like in it, right?
Yes, NSO package. So I'll tell you about NSO. So NSO, the heart of NSO is something called FastMap. Then there is device manager. And there is service manager. So there is this device model, service model, and this is the nets, net 1, net 2, net 3. It can have multiple nets, means the number of devices you have, the number of nets you can, means the number of types of devices you have, the number of nets you can use. So it's not that if you have 1,000 devices, you need 1,000 nets. If 1,000 devices are from the same vendor, you need just one net. Okay. So this southbound communication with the devices is with CLI. So the protocols used are SSH or Telnet, or it could be with netconf. So we prefer netconf because the world is moving towards netconf, but if the vendors are not supporting netconf, we use CLI. And on the top, you have the API architecture, which is called northbound API. So you have RESTconf, you have netconf, you have JSON RPC, and programmatical APIs called Mappy and Magic. Mappy and Magic. FastMap, and there is another thing here called CDB. I'll talk about all of this. CDB. So starting from the bottom, nets we talked about this network element driver. Each vendor, there is a piece of code which is compiled along with the NSO and gets inserted as a module. Now CDB is configuration database. It's an in-mem database. So in-mem databases are databases which stay in the memory. And this database is in the form of XML path structure. So if you want to traverse this database, it is XML kind of traversing with XPath expressions. Okay. Then there is a logic, a patented logic engine in between, which is called FastMap. So FastMap, I'll tell you the importance of FastMap. For now, let's just call it a logic engine. On top, on the left side, we have the device model. So devices are modeled in the form of nets. So device model will have YANG model as well as the template for the device, the CLI template for the device. It comes in a complete module called device manager. There are service models which we create. As NSO developers, we create service models and we put it inside the service manager, and we use a mapping logic. So why mapping logic is required? Because this service model which we created, it's in YAML. So we declared the different kind of data structures and variables. But for creating the service, we would need to map this service model variables into the device template and then push it to through net. So that is why we need the mapping logic. So all the callbacks like create callback, edit callback, all these callbacks and mapping of values with the variables in an XML format happens in this mapping logic. This mapping logic can either be written in Java or Python. Device templates. Device templates are in XML. So each device CLI, we convert it to XML form, and then we use the template, the service model, and the mapping logic to create a service. So this is like a one-time exercise. We create these three things as part of service development in a one-time exercise. This. We have another one. Template, mapping logic, and the service model. These three are created only once. So we spend like maybe 2 weeks, 3 weeks, or a month time to develop this in a very professional way. Once it is done, then creation of service becomes less than a minute job. Just put the value, commit, put the value, commit. So that is the overall architecture of NSO. Now FastMap, what it does is, suppose you have created the create callback or create function in the mapping logic with the code, Java code or Python code, you have done it. So FastMap, what it will do is, it will study your code automatically and it will automatically give you the edit and delete callbacks. You need not to write edit and delete callback for a service. So only thing you must be worried about creating the create callback. So once you have created the service, delete, update, edit, all these things FastMap will handle.
So basically, on the mapping logic part, like we are only creating the service, right?
Yes. Model यहाँ पे create कर रहे हो, device template यहाँ create कर रहे हो, और mapping logic में इसको use कर.
Like device name, interface name को map कैसे करेंगे?
Map कैसे करोगे?
Interface जो आ रहा है, यहाँ पे interface कैसे map करेंगे? उसका name है वो different हो. यहाँ पे interface का name different है. दोनों के variables हैं वो mapping.
You are like
mapping it with this XML.
You are converting it to Java and Python.
Yes.
And converting, showing it into XML.
Correct.
And that XML is pushed through
nets to the CLI of the device. And as soon as I create a service model with a template and mapping logic, NSO inbuilt engine automatically creates a not-bound API for that service model. So correct. So there are two kind of APIs available. One is a REST API, one is a JSON RPC interface. So that is what you use in your BPA when you push the payload to NSO. So if I talk about BPA, BPA sits here. Here is your BPA. So NSO, when Cisco acquired NSO, it didn't have a very nice UI. And the UI was, all of you must have seen NSO UI. It's good, but it's not very predictive, I would say. Sometimes if your YANG models are very complex, then UI can also have troubles, evaluating the when expressions and all. Because, sometimes in YANG models itself, you do a lot of, I would say, if then else kind of logic, that if the service is L2 VPN, then you bring up another container. If the service is L3 VPN, you bring up another container. Or if it's a gigabit interface, you bring up something else. Means, suppose if I'm going by a car, then I should take a different road. If I'm going by a bike, I should take a different road. Something like this, if then else you do in the YANG models. So your UI should adapt to that. So that one is like, sometimes it works, sometimes it might have some challenges and all. and there was no workflow capabilities, and also in order to give a complete package to the end customer, we had this very nice, but without a proper UI and a workflow, this usability of all this was like, getting a bit diminished. So we created this BPA, business process automation tool. So it's a UI sits on top of NSO with microservices architecture, and you use JSON RPC or REST-conf API to talk to your NSO. So this modeling is done by Cisco as of now. They prepare these packages, they give it to you, and then you develop this. So with a few more sessions, you would even be able to do this. I'm sure you will be.
So what configuration you save in CDB?
Okay, so CDB has both device and service configurations.
Both are saved here.
Yes, both are saved here in CDB. So CDB architecture is something like this. Maybe I'll show here. CDB has tree kind of architecture. Okay, so this is root. Dot is root. Okay, and there is a devices tree. Devices. Then in the devices you will have device. In the devices you will have your routers. In the routers you will have your interfaces, your different configurations, all that stuff. Then there will be a services tree. Services, inside the services you will have service. Then you have whatever you have configured. If you have configured L2 VPN as a service package, or whatever service package, maybe as simple as a service package like an IP phone onboarding service package, or maybe a video endpoint onboarding service package, or a perimeter security service package, which is only putting just a rule on the firewall. Could be a service package. It's just a matter of modeling something and putting it there. Then there is alarm manager, there is notification manager, all that stuff. So suppose if you want to access this router 1 in the CDB, so how you will do the XPath expression is /devices /device/RTR1. Maybe if you want to access some interface, then /something something, and there are
sometimes the expression starts with NCS.
Yes, so all this, how it will happen? Very good point. So in JSON RPC, it is like NCS : devices, NCS : device, NCS : so there is an NCS : and there are like, if there are multiple interfaces, then it will be like in square brackets, square braces, ID equal to, and you put the, so these are all semantics, how to use the XPath expression, and I will also show you how to figure out what is the XPath of a particular resource which you are referring to. So you can log into NSO CLI and you can check the XPath in the CDB, right, if you are referring to the right XPath or not. Sometimes if you are doing any mistake in the XPath, the API will not work.
Sir, what is day 0 configuration, which is also stored in CDB?
Okay, so shall I rub this now?
Yeah.
So Mohit, before this, I have a question on this device model.
Yes.
So this device template directly comes with the device, or we should create it, like we have to create it
Okay, so for the services, we have to create the device template. So what happens is, the actual configuration for the service comes from the network engineer. Okay, so the network engineer will give you the CLI, that this is the CLI. If I put on 3 devices, my service is operational. So based on that template which you receive from network engineer, you go to NSO, you put that CLI in NSO CLI, and then you convert it into XML. So then you get an XML file of that configuration. Then you decide what are the variables, what are the constants there. Variables, you model it in YAML, and then you do the mapping logic, and some of the variables like sudo wire ID or IP address, you can have your Java code allocate the pseudo-wire IDs also automatically. You start from 1 and then next is I++, I++.
Okay.
Okay. So day 0 and day 1. I'll quickly, this will be the last topic for today because we're already running out of time for today's session. So day 0 and day 1 is like, so sorry guys. So when a new device comes in to the network, then it is called day 0. Day 0 means शुरुआत, start. नया device unpack किया and cable लगाया, and then what configuration you put it to bring it to the network is your day 0 config. So day 0 is your startup or initial. I would say initial instead of startup. I would say initial config for new device or new device. Like if you inserted a new PE router in the network, you will have to put some configuration, like you have to make the LDP pairing up, you have to make one IP address on the interface to connect it to other P routers or something like that. You have to put the IGP protocol up. So all that will come to day 0 configuration. Once the box is up and running and is ready to accept new services, then the services configuration or the operational configuration which you will put on the box is mostly called day 1. So it is more of a term which is widely understood in the industry that day 0 is shuru hua box, naya box aaya, day 0, and then from the next onwards it becomes day 1. And then there is another term on top of this is day 2. So day 2 is more of operations and support. So if you are putting new link, if there is a change management happening on the box, change management means maybe you want to increase the capacity on the links. Suppose you have got only gigabit links, you want to put more fiber and make that link part of the bundle. Means it's more of an operations. So that is day 2. Day 3 अभी नहीं use होता है. मतलब day 2 तक ही it is like when the box is end of sale, end of support, then you swap the box, you again put a new box, day 0 starts. Cycle gets started. And the same goes with any of, like in BOA, I understand you guys do a lot of IP phone, new IP phone introduction and all that. So if it's a new IP phone which is coming in your workflow, it is mainly day 0. If there is an IP phone already existing, but you just need to configure the service, it is maybe day 1. If service is also there and you just want to make some change in, maybe suppose it was my IP phone, it is changed from mine to Shirish or yours, then it is maybe day 2. Operational team will be doing all this day 2, or maybe a software upgrade.
Like
day 2.
Cisco and NSO, so all players.
Yes. So just like Cisco NSO, Juniper has something called Contrail. Sienna has something called Blue Planet. So what is NSO? NSO is a services orchestrator. Orchestrator is a software or an equipment which automates your service management life cycle from start till end. Orchestrate means shuru se sab kuch automate kar diya. So NSO is a services orchestrator. Other players like Juniper, Sienna, others also have similar orchestration engines called Contrail, Blue Planet. But NSO is one of the leading ones, and it uses YANG and NetConf, which are IETF standards, industry standards. Other orchestrators might not be using the standard protocols. They might use some proprietary code in their engines. So they are not very popular, because if you are going with the standard, it is more scalable and future proof. And in future also you can continue to use it, and it has a northbound API. You can integrate it with your CRM systems, with BPA, with whatnot. Right. So that's all for today, guys. Thank you very much for your time. and I'll share some material as well. And I think this recording will also be available shortly. I'll share this recording as well. So those of you who might not have got time to attend this session can go through the recording, or even if you want to go through this video recording once again to refresh what we learned today, you can do that. And in the next session, we will start with some small work on NSO. So I would expect most of you have Ubuntu on your computers, and maybe NSO also on your computers. If not, Ubuntu is enough, and we will start from there. Okay. Okay. Thank you, guys. Thank you very much, and have a wonderful day ahead. Bye bye.
Thank you. Thank you. Bye.